All right, so yesterday we talked about multiplication. Today we're going to revisit addition with the Algebra 2 twist again. Before getting to those problems, let's revisit the general idea of the process. Remember that in order to add or subtract fractions, you have to have common denominators, that you add or subtract the numerators, and you leave the denominator as is. Simple, right? So now let's check out the problems again. Remember to make note of subtle explanations I give you so you have a foundation of understanding. It is great to copy notes, but again, if you look at those notes later on tomorrow and you can't remember why something equals what it is, then you did not take good notes. And again, if you're going to be in honors level math classes and eventually taking higher level math classes in college, you need to understand your notes are you teaching yourself. Now, yes, you copy what I write, but if you don't understand exactly when I write it, why something happened, you need to write off a little note to say multiplied, whatever, or whatever little explanation so you know to always get that part from your notes. That is how you take winning notes. Now, getting this together, the general idea here, we have a common denominator, which means we're going to add everything together. So again, 2y plus 4 plus 4y plus 9. I can put the y's together, getting 6y plus 13 all over y minus 3. And that is the general idea of how you add and subtract fractions. You just combine your like terms up top, leave the bottom alone, and that is great. Unfortunately for you, it's not always going to be that easy. It will be more like this. So if you're asked to find the least common multiple of two things, the first thing you must do is factor. So I'm going to look at this and say this is going to be, this is going to be good. First off, I can pull off a 5, and I'm left with w squared minus 4. But your factoring has to be on point because w squared minus 4 can turn into w plus 2 and w minus 2. So based off of what I'm looking at, I have one fraction with, and I'm going to label them, one fraction with 5 times w plus 2 times w minus 2. And I have fraction b with w plus 2. Now here is the rule with your least common denominator, or least common multiple. You have to have room for everything that one fraction can give you. Here's what I mean. This fraction has a 5, which means my LCM must have a 5, or have room for a 5 to be there. This has a w plus 2, so that means I need room for w plus 2. This also has a w minus 2, which means I need to make room for w minus 2. Well, here's the thing. This has a w plus 2, but I already have room for the w plus 2, which means I don't need to write it again. The only reason I would need to write another w plus 2 is if this had 2 of them, and I would need 2 of them here. But based off of what I see, I need room for 1 5, 1 w plus 2, and 1 w minus 2. And because this is only 1 w plus 2, then I don't need to do anything else. This is your least common multiple. So again, that's what our work is pretty much today about. Make room for everything in the denominator, and then we make the answers actually work. So here we go. Factoring the bottoms. This becomes x times x minus 5. This becomes 5 times x minus 5. So again, looking at this, and for adding, I would always do it off to the side. That way you don't get lost because it's easy to do. I need room for an x, a 5, and an x minus 5, because notice that only has 1, that only has 1. So I guess it'll be 5x times x minus 5. That's first. The second thing you must do is you have to ask yourself what's missing. Well, what's missing from here that we have over here? Well, the x is here, the x minus 5 is there. I need to multiply by 5, right? Over here, when I'm looking at this, what's missing? I have the 5, I have the x minus 5. This is missing in x. And so what you end up with is this, which ends up being 25, minus this, which ends up being x squared, all over whatever your common denominator is, which is 5x times x minus 5. Now here's again where attention has to be paid. 25 minus x squared seems to be like difference of squares, which means, again, I'm going to do this in the problem, that if I take out a negative, I can actually make this x squared minus 25, which means I can actually make this x plus 5, x minus 5, which means I now have something I can cancel on the bottom, and now your organization comes in. Please pay attention to what I did. I put a negative there, and there's only one negative number there. That means my fraction is going to be negative. My x plus 5 stayed, my 5x also stayed. And remember, I cannot touch this 5 because it's married to that x and I cannot do anything with it. So negative x plus 5 over 5x is our answer. Again, ignoring that this was even there, I noticed that that might be able to factor, so I did some work. The first thing I did was take out a negative and flip it around like we did in our last one. Then I factored it and notice that it did actually come out for us to get our answer. Again, the way you do these is you factor. Multiplies to make 3, subtracts to make 2 is 3 and 1, so x plus 1, x minus 3. Here we are looking at multiplies to be 3, adds to make negative 4, so x minus 1, x minus 3. And so remember, for your LCM, we are looking for room for everything. I need room for an x plus 1. I need room for an x minus 3. Already have room for that, but I need to make room for an x minus 1. So again, notice I have 1 x minus 3 on the bottom, which is why that's there. I have an x plus 1 there. I have an x minus 1 there. So in terms of what's missing, this seems to be missing an x minus 1, which is why I want to multiply by x minus 1. The reason I use parentheses is because that reminds me I need to distribute. On this one here, and here's what I would do because this is going to get crazy. Actually, I'll do it afterwards. This here is missing the x plus 1. But before I distribute, remember that minus negative signs are bad. So what I'm going to do is change it and put it up on this 5. That way I don't overlook it. And so we end up with 3x squared minus 3x, I just distributed is all, minus 5x squared minus 5x. That's why I wanted to make sure my 5 was negative, because otherwise I forget that that should not be a plus 5. It's a minus 5 all over x plus 1, x minus 3, x minus 1. Now, based off of what I see, that actually might work. Let me split this. Actually, let me do that over here. So I'm going to split it. I'm going to factor it. Let's see what happens. I can take off a 3x, and I'm left with x minus 1, which is what I thought. And then minus, I can take off a... No, you can't do that. So that doesn't factor, which means we'll just simplify it. I was just making sure it didn't factor to be something else crazy, and actually it might, but we'll see. So I'm just going to go ahead and put my like terms together. So 3x squared minus 5x squared is negative 2x squared minus 8x all over all this junk here. Now the key thing to look for is if we can pull out anything that's going to make this cancel, but that would just be x minus 4 from what I would see, because 2 and 8 factor down to be a 4, and there is no x minus 4 or x plus 4, which means that this is going to be your stopping point. Could you factor off your 2x? Sure. Could you factor off a negative 2x? Sure. But typically in this realm, if it doesn't lead to canceling, you don't factor. That's the reason why I took this over to see if I could factor it, because I was thinking I might have an x minus 1 hidden. But once I recognized that you can't put an x minus 1 there, because notice how these two have different signs, but these two are both negative, that means that it would not be a positive x and a negative 1. It would have actually been a negative x and a negative 1. But again, feel free to try to factor it, and you will see for yourself that it does not work. E is a complex fraction, but it should not be an issue because I don't think adding fractions is scary. What I will do is work both of these off to the side. So 5 plus 2/5 means I need a common denominator of 5. And the way I rewrite 5 with a denominator of 5 is to multiply by the denominator and put the denominator on the bottom. So 25/5 plus 2/5 is 27 over 5. 4 minus 1/7 means I need a denominator of 7. Means I take 7 times 4, turn this into 28 over 7. 28 minus 1 is 27 over 7, which means that this turns into 27 over 5 over 27 over 7. Now here's the general rule with your fractions here. Typically what happens when you have a fraction in a fraction is that the denominator of the fraction switches sides. So the 5 actually moves. Well, the denominator of 27 and 7 is the 7, which means that that actually moves up. meaning that you end up with 27 times 7 on top because 7 moved up, and you end up with 27 times 5 on the bottom. In the end, the 27s cancel out, giving us 7/5. Now, it's important for you to be able to do that on your own, but if you're taking the ACT, I expect that you would just learn how to program this thing into your calculator. 5 plus 2/5 over 4 minus 1/7 equals, and look at that, 7/5. So like I said, I expect that, but again, you've got to understand where it came from if you're going to be a higher level mathematician. So therefore, that's what it is. Or what you could do in this problem is you could actually rewrite it as 27/5 divided by 27/7, which therefore means change and flip. So 27/5 times 7 over 27. In that case, that's also how you could do it. So there's a few different ways. Just make sure, again, you pick one that's comfortable for you, because you have to know how to do this at some point. You never know when you'll need that higher level math, but again, it's got to be there in your head somewhere in order to survive. So looking at this one, the only way I can deal with a complex fraction is if I have a fraction over a fraction. This one needs to be combined with this x minus 6. So I'm going to go off to the side and do this work. And what that means is, same rule, multiply this by that, which makes x minus 6 over whatever denominator I need, which is x minus 6. Now look at this carefully. Anything divided by itself is 1, so I did that right. Which means I'm doing x minus 6 minus 1, which means I actually have x minus 7. Look carefully at that to make sure you understand it. I am putting negative 6 together with a negative 1 over x minus 6. Again, denominator stays the same because that's how you add fractions. But combining these, negative 6 and negative 1 makes x minus 7. So therefore, this turns into 1 over x minus 6 over x minus 7 over x minus 6. Which therefore equals, well, again, I'll do it the easy way, which is 1 over x minus 6 divided by x minus 7 over x minus 6, which means I then need to rewrite this as 1 over x minus 6 times x minus 6 over x minus 7. And remembering what we did with multiplication, these two things cancel, leaving us 1 over x minus 7 as my final answer. And again, I'm pretty sure I could probably take a picture of this with my phone, but that's not going to get you through the SAT. Actually, if you have a phone out on the SAT or ACT, they just cancel your whole score, and you have to pay the money and take it again. So that's why I'm trying to teach you not to use that stuff, because all it's going to do is cost you a bunch of money and time. So again, with fractions inside of fractions, I'm going to put these together. So 2 over w plus 3 over x. We need a common denominator. To me, I think it's going to be wx. Actually, in one this simple, you can just kind of do the multiplication thing, but wx is going to be my denominator. This is missing an x. This is missing a w, just like we did on the other ones. Again, if wx is my denominator, I got to figure out what's missing. So this ends up being 2x plus 3w over wx. Looking at this one here, 3 over w minus 2 over x. Again, the denominator is going to be wx. This fraction is missing x. This fraction is missing w. So it ends up being 3x minus 2w, which means in the end your fraction converts to be, because I rewrote that, 2x plus 3w over wx. That's that fraction, all over 3x minus 2w over wx, which then turns into the division problem. So 2x plus 3w over wx divided by whatever is on the bottom, which is 3x minus 2w over wx, which then changes because I have to flip this to be 2x plus 3w over all this junk times wx over all this junk. Notice how wx is on top and bottom, so they go away, leaving me with 2x plus 3w over 3x minus 2w. And remember, I can't cancel just the 2 or the 3. Now here's what's interesting. The math student in you should be able to answer the question on your homework because this is on video. And what you should be able to do is watch this again, follow the steps I did, and try to get pretty close. if you're sending me an email saying you have no clue how to do it, when I'm walking you through this specific question from your homework where the numbers might be different, then you're telling me something. So make sure you try to get something on paper before you say you don't get it, because I just walked you through it right here, and something should be, you know, on paper that you can show me and I can say, hey, this is where you messed up, instead of you saying, can you explain to me how to do it? Because in all honesty, I just explained it. I took this over here and simplified it, took this over here and simplified it, rewrote both of those fractions, rewrote as division, flip the second one, and cancel what was there. But again, if that happens, that's fine, but make sure you try to get as much as you can on paper before just giving up. Now this is where we need our common denominator. So again, in order for common denominator, I have to factor. Multiplies to be 14, subtracts to be negative 5 will be x plus 2, x minus 7. Hey, it's the same one. That's boring. Anyway, I guess we'll do it. That also is x plus 2, x minus 7. I think I remember that when I was going over it. So because that's my least common denominator and they're both the same, all we are going to do is put these together. Now here's where you want to be careful. Remember I told you that negatives are crazy. So kind of like when we did long division, I'm going to switch this, and I'm also going to switch everything up there, because it is distributed the negative, which means both of those numbers had to change. So 7x minus 6x is just x. Negative 1 and negative 6 makes negative 7. So I guess it's a good thing I factored them, because now notice that x minus 7's cancel out, giving me 1 over x plus 2. You want to make sure you factor at least to start or to end it. That's why I just go ahead and factor early. But again, the reason you factor is because you don't want to put x minus 7 over x squared minus 5x minus 14, because there's a factor in there that could be canceled out, and this would be marked wrong. And I can't give you credit for that, because I'm telling you right now, you need to factor everything you can, except in the final answer when nothing can be factored out. So the only time you really don't factor is when nothing can come out, but you need to factor to start. So this is interesting, because on this I see that a 2 goes into 2, 8, and 20, which means it's actually 2 times x squared, 4x, and 10. Is that right? It is. And I don't think that can be factored, because if 2 comes out of that, that becomes a regular x, that becomes a 4, that becomes a 10. There are no numbers that multiply to be 10 and add to be 4. The only numbers that multiply to be 10 are 1 and 10, or 2 and 5, and those don't make 4. So that's as much as I can do there. All right. Multiplies to be 8, adds to be 9. That's easy. X plus 1, x plus 8. Multiplies to be 8. Actually, all these are the same again, so that's easy enough. So maybe I should just leave that as it is, because if I factor it, then that means I'm going to have to just undo it anyway. So what I'm going to do is ignore that, because to me, since all these are the same, I can simply just combine all the like terms at the top. So here's what's going to happen. I am going to distribute this negative to all three of these things. So switch, 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 switch. And then I'm going to put it together. So 2x squared and 3x squared is 5 minus 4, which is just x squared. 8x minus 13x is negative 5x, plus 5x actually goes away, so that's 0. 20 minus 98 is negative 78, plus 14 I believe is negative 64. Oh, this is interesting. All over what I factored, which is here. Again, all I did, even though I factored that, what I recognize is that since this denominator is just the same, all we're doing is combining like terms anyway, so I ignored that line and just kind of put it together. Again, 2 plus 3 is 5, 5 minus 4, 1. 8 minus 13 is negative 5, negative 5 plus 5, gone, that's why there's no x. 20 minus 98 plus 14 is 64. And this is where your factoring has to be done, because notice that's x plus 8. And this factors would be x plus 8, x minus 8, which means your final answer is actually x minus 8 over x plus 1, which again is very important for you to be able to find. Now I am not going to work out all these questions, but I will at least get you started on them. So here we go. I will start this for you, and then leave the rest to you. So 49 and 5 have to find a common number. I believe 49 and 5, because they're both very, very weird numbers, is going to be 245. But here's the thing. There's 4 x's here, 3 x's there, and I need room for the most possible, which means I need room for 4 x's. There's 8 y's here, 5 y's there. I need room for the most, which is 8 y's. So that would be your LCM. When you go to see what's missing, obviously 5 is missing 49. I'm not missing any x's, but I am missing, if you look at that, I have 5 y's, I need to have 8. I'm missing 3 y's, which is what you would do there. Here, in order for 245 to be there, I'm missing the 5. So 5 comes down. I have 3 x's, I need 4, so I need 1 x. And pretty much I'm saying what's missing from here that's over here, I have all my y's. So there we go. I guess I can answer this. 7 times 49, I believe, is 343 y to the third minus, because again that's going to be a -2, 10x all over all this stuff here. And again, I cannot cancel this x and that y because I would have to have a full factor to do that. So it's impossible. I will show you this. Did I write this wrong? I feel like I did. X to the third. What was I thinking? I think this problem's off. If you see this and you have an issue with it, let me know, but I'm pretty sure that's supposed to be the same on all 3, and I probably just got tired of typing. But what you would do on this, again, is factor the bottom, factor the bottom, factor the bottom. 8, 9, nope, that doesn't factor. And that doesn't factor. But anyway, after you get all that done, you would put your like terms together and go from there. I don't know what that was, but we'll move past that. U and 5u. I have to make room for a u. I have to make room for a 5. Notice that the u is already there, so my LCM is just 5u, which means if I'm asking what's missing from here that's over here, I am missing a 5, which means that becomes 15. What's missing from here that's over here is nothing, so it's plus 9 all over 5u. Again, 3 times 5 turns into 15. The bottom's already the same, so 9 comes down. 15 plus 9 turns into 24 over 5u, and that is all. All right. It's going to be fun. This is again where we have to kind of think about what happened in our last lesson. X minus 7, 7 minus x would be very, very close if this was flipped. But the only way I can flip it is if I make this x minus 7 and make this 5 negative. Remember, the only way I can flip it is if I put a negative into the mix of that problem. But now that these are both x minus 7s, I can now do 10x minus 5x, which is 5x over the common denominator of x minus 7. So these are all things you have to be ready for. Again, if you have to watch the video, watch the video. But the key thing is make sure you pay attention to what's going on. So when I factor this, this is x plus 2, x minus 2, which means in terms of my LCM, I need room for an x minus 2, which is done. I need room for an x plus 2. I already have room for an x minus 2, and I already have room for an x plus 2 because that's only going to have one x minus 2, which is fine. This is going to have one of each, which it has. This is only going to have an x plus 2, which it has. So when you look at it, what's missing from here that's over here? And that would be x plus 2. What's missing in this denominator is nothing, so leave 48 alone. Remember, the best thing to do is change my 6. What's missing from here is an x minus 2. So this ends up being 6x squared plus 12x plus 48 minus 6x squared plus 12x all over whatever your denominator is. So again, making sure 6x squared plus 12x plus 48 minus 6x squared, which means these two things cancel, giving us 24x plus 48 all over this here. And if you look carefully, I think the factor of 24 and 48 is 1 and 2, which means I think I can actually factor that. So that'll be 24 times x plus 2, which means those two things cancel, giving me this answer. This is why I said even though it is your easiest chapter, because we will not have any big sets of work, it still is going to take work for you to get this stuff done, especially if you want to do it the right way. This one here, again, I'm not going to worry about factoring that just yet because I don't want to mess with it, but I do recognize x to the third, y to the third. That's 7 times 7 times 7. I believe that is 8 times 8 times 8. Or is it? We'll see. Yep, it is. So these are perfect cubes, which means that this is the perfect cube of 7x plus 8y. And let's see if you remember the formula. It is a squared, which means 49x squared. Switch the sign, so minus ab, which would be 56xy, plus b squared, which is 64y squared. And look at that, it matches what's on the top. So my LCM has to be, I guess, that, exactly what's here, because I already have a 7x plus 8y there. So anyway, this is what ends up on the bottom. And what's missing from this is the part there. So I'm going to multiply all that. I'm actually going to, what am I going to do? Easy way to do this. Is there an easy way to do this? You know what? I think there is. I'm going to put these together by just using 6 times that. So since I'm going to put all this junk up there because that's what's missing, I'm going to write that here. So 6 times all this stuff. Because that's what I would have to multiply by. Minus, and I'm just going to put it in parentheses, this. And there's a couple different directions we can go. Number one, we can factor this off. Number two, we could say 6 of these minus 1 of these makes 5 of these. And in the end, these two things cancel, giving us 5 over 7x plus 8y. Such a beautiful problem. I love these things. They at least challenge me a little bit while I'm working through them. And as we're getting close to 30 minutes, we will be about 30 minutes, but hey, it's worth the cause. I'm doing all your homework with you for the most part, except for that one weird one that I absolutely screwed up. So again, what I did yesterday or last lesson was area, making sure you know area, but again, this is going to be perimeter, which means it is going to be, they want the perimeter and area. So for perimeter, I believe you would put 2L, 2W, but I'm going to just keep it simple. I'm going to do 4A minus B over A plus 4A plus B over A plus. That's going to be the same. Plus, and then just keep it simple. The bottom's going to be the same. And then that way I can just put it all together because all these have the common denominator of A, which means that I just simply add the top. So 4, 8, 16, I'm sorry, 12, 16A. Negative B, positive B would cancel. Negative B, positive B would cancel. Look at that. And A is on the bottom of all those, which means A is my denominator. 16A over A is just 16. Interesting. But again, all I did was add this plus that plus this, which would be the same as that side over there, plus this, which would be the same as its opposite over there. Put all my like terms together at the top, bring down my A, and be done. The area, if you remember, is length times width. That means it is 4a minus b over a times 4a plus b all over a. There's nothing to cancel. So therefore, we have to actually multiply this out. So keeping in mind those are conjugates. Remember the rule for conjugates is that the middle term cancels. You end up with 16a squared minus b squared all over a squared, because a times a is a squared. I cannot touch the a squared because this is all part of a married group. That would be your area. Very messy question, but I like messy questions. It's good to develop character. So make sure you do your best to understand this stuff, and I will talk to you later. Again, email me your questions, but make sure before you ask too deep of a question in terms of saying I don't know how to do it, that you try to watch the video and follow along with the numbers you have, because I literally just pulled these from your homework problems and copied them so that you could actually see me work them out. But like I said, just let me know what's going on and we'll go from there. Have a good day, and I'll talk to you later.